2 months ago, I reported on changes in Arctic sea ice over the last few decades, raising the possibility that those changes might have an impact in the mid-latitudes. Last week, a visitor to our department showed some fascinating data that gives more insight into what's happening at the top of the world. There's no doubt that the aerial extent of sea ice in the Arctic has dramatically decreased since satellite measurements began in 1979, especially if you focus on the end of summer, when sea ice typically reaches its minimum. Arctic sea ice extent in mid-September 2012 was the lowest in the satellite record, and in fact the 6 smallest September sea ice areas all have occurred in the last 6 years. But the surface area of Arctic sea ice isn't all that's changing. The ice is also getting thinner and younger. To understand how, realize that Arctic sea ice moves in a very slow wind-driven circulation that has 2 primary parts. The Beaufort Gyre is a clockwise circulation in the Beaufort Sea, north of Alaska, driven by a high-pressure system which, on average, dominates the atmosphere there. The other part is called the transpolar drift. It moves ice from the Siberian coast across the North Pole to the east coast of Greenland and eventually the North Atlantic Ocean. Ice in this current tends to leave the Arctic in a year or two, whereas ice trapped in the Beaufort Gyre can grow pretty thick and tends to be older. But in the last decade, this conventional thinking has changed. Check out this animation that tracks the movement and age of Arctic sea ice month by month starting in 1992. To get oriented, Alaska is bottom left, Russia top left, and we've marked the North Pole. Colors indicate the age of the ice. White means more than 9 years old. The darkest blue is ice that formed in the most recent winter, so it tends to be thinner and easier to melt. You'll see that, especially in the last 10 years, this younger, more melt-prone ice begins to dominate the Arctic. In just the last few years, the older ice, the white, is mostly found in a sliver along the Canadian Arctic Islands and northern Greenland, while very little of the older ice is left in the central Arctic. Because older ice tends to be thicker, its disappearance translates into a big loss of ice volume, which in the end matters more than area if you're trying to assess the total amount of melting. Here's how Arctic sea ice volume has changed since 1979. Back then, the winter maximum was around 30,000 cubic kilometers, the summer minimum around 20,000. Though there's plenty of variation from year to year, the trend towards smaller ice volumes at all times of the year is pretty clear. In just the last few years, the summer minimum has dropped to around 5,000 cubic kilometers, a loss of 75% compared to 30 years ago. That's one heck of a big change at the top of the world. And regardless of why this is happening, such a large shift from ice to water has to alter the exchange of heat and moisture with the atmosphere and have consequences that we are only beginning to understand. Fred is back with the extended forecast next.